may have just learned that there is a way that you can earn free Ranger Bucks while you're sitting at home anyway. And when we get back, we will hold a big class auction where any money that you earn during this time you can use for that special class auction. There will be some great things to purchase, like eating lunch with your teacher or maybe sitting with a friend for a week at school. So what you need to do is tune into the videos, follow the Canvas module, and find your way earning free Ranger Bucks. Okay, so today what we're going to learn about is how to classify triangles. You know what a triangle is. It's a three-sided polygon, and you've seen triangles since you were like this little, right? So what we're going to do is we're going to learn 3 ways to classify triangles today. Remember, classify really just means to name a triangle. So they have different names, and it's based on their angles. Let's learn more. Okay, so here it is. We're going to classify triangles. Remember, classify just means name, to give a name. So we all know what a triangle is. It's a polygon with 3 sides. So let's get started. In 4th grade, we're only going to learn about 3 names that we give triangles. This is the first triangle, and when I'm trying to decide how to classify a triangle, I look at its angles. And if you look here, you'll notice this angle here is acute. It's obviously smaller than a 90-degree right angle. And this angle here is also acute. It's smaller than a 90-degree right angle. And this third angle here is also acute. When all 3 angles of a triangle are acute, we simply call it an acute triangle. So if I wanted to classify this triangle, I would call it an acute triangle based on all 3 angles are acute. But not all triangles have 3 acute angles. Let's look at what to call them. Now, you'll notice that these 2 angles here are acute on this triangle. But there's one angle that's different right here. This is a right angle, a 90-degree angle. Anytime there is one right angle in a triangle, we simply call it a right triangle. So far, acute triangles, all 3 acute, and a right triangle if it has one right angle. Okay, there's only one more to learn. So we can see here that these 2 angles are acute, but when I look at this angle here, this is an obtuse angle. It's larger than 90 degrees. And so I simply call this triangle an obtuse triangle. So anytime a triangle has one obtuse angle, we call it an obtuse triangle. So let's go back over them one more time. We've got an acute triangle. Remember, all 3 were acute angles. We have a right triangle. All it takes is one right angle to make it a right triangle. And then we have the obtuse triangle. And all it takes is one obtuse angle, and you classify it as an obtuse triangle. Okay, I think that you're ready for some practice. Are you wondering what this bucket has to do with geometry? Well, I'm getting creative here because I'm stuck at home, but I just want you to look at this circle. Today we're going to be talking about how angles are literally just parts of a circle. Every circle has a center point, and we can make rays go out to the edges, and that forms angles. So we're going to learn today how each angle is just a fraction of a circle. It's just a part of a circle. So let's get started. Okay, here we go. During this tutorial, we're going to learn about how every angle is really just a fraction of a circle. It's a part of a circle. So let's take a look at this circle. You can see here, I'm going to draw my best attempt at a 90-degree angle. It's not perfect, but you get the idea. This is a right angle, and we know that it is a 90-degree angle. That would be the measure of the angle. And if you look at it as part of a circle, it's 90 degrees out of 360 degrees, because we've learned that an entire circle has 360 degrees. A right angle is 93/60ths of a circle. That fraction is also equivalent to 1/4 of a circle. As you can see here, if I shaded in this part of the circle, I would have 1/4 of the circle shaded. So what about when you have other angles? So let's try this one. Let's say that this angle is probably somewhere around, we'll say a 30-degree angle. Well, remember, it's just a part of a circle, so it is 30 degrees out of 360. Remember, the denominator of a fraction tells you how much is in the whole thing. And in a circle, the whole thing is 360. And the numerator of a fraction tells you the part that you're talking about. And here you are literally talking about this 30-degree angle as part of the whole circle. Let's try another. This time we'll do an obtuse angle. I'm thinking it's probably somewhere around, let's say 135 degrees. So it is 135 degrees out of 360 degrees. So here you can see how this angle is just a fraction of the circle. So we can name angles in this way too. So just remember, every angle is a part of a circle. Okay kids, up next is how to figure out the measure of one angle when you have adjacent angles. Adjacent angles sounds like a big scary word, but I promise you it's not. I'm going to show you in this video how to figure out measures of angles when you know the ones next to them. It's going to be so easy, and as easy as part whole. So let's get started. This tutorial is all about finding the measure of an angle when you know the measure of its adjacent angle. Adjacent literally means that it shares a ray. And let me show you what I mean here. So we have a point, and here is a ray that is extending from that point, and here is another ray. But I could have even another ray extend right here. And I could tell you that this, from here to here, this angle here is 160 degrees. And then I could even take it a step farther and tell you that this angle here is 45 degrees. And now what we need to figure out is, what is the measure of this angle here? Well, because we know the whole angle is 160, and we know that part of it is 45 degrees, all we have to do is 160 minus 45, and we will know what this part is. And so you would end up with 115 degrees, if I did my math right. Yes, I did. Yay. Okay, so now we know that this angle here, from this ray to this ray, measures at 115 degrees. So how I want you to think about this is part, whole. When you have adjacent angles, you could be given different things. You could be given both of the parts, like maybe this is 30 degrees, and this is 40 degrees. See, you have this part and you have this part. And what they might ask you is, well, what's this whole angle? So when you have a part and a part, you add together to get the whole. So the whole angle here would be 70 degrees. So that's one type where you might have part, and you need to find the whole. And then there will be times where you know one part and you know the whole, but you're missing one of the parts, and that shows you to subtract. You can think of this a lot like when we do a strip diagram. When the whole is unknown and you do know the parts, like let's say 30 and 20, in order to find out how much the whole thing is, you add. But sometimes with strip diagrams, you know the whole and you know one part, but you're missing the other. And this would tell you to subtract 110 minus 15, which would be 95. So that's really the same concept when we're looking at adjacent angles. Let's try another one. What if I told you that the whole angle is 90 degrees? And I might not say that. I might even just draw it like this, and that would tell you, oh, that's a 90-degree angle. And what they do is they might tell you, but this angle that's right here is 10 degrees. So now you have to figure out the missing angle, the measure of the missing angle right here. So remember, we know the whole angle is 90 degrees, and we know that part of it is 10. Since we're missing a part, we subtract 90 minus 10, and we end up with 80 degrees. So now we know that this missing angle was 80 degrees. Sometimes you might see a straight angle. Remember, a straight angle is 180 degrees. It's half of the circle. Well, as you can see here, we still have two adjacent angles. They are sharing the center ray. So, if we know that the whole is 180 degrees, and then maybe they tell us that this angle here is 160 degrees. But the question that you're trying to figure out is the measure of this adjacent angle. Well, remember, you know the whole is 180 degrees because it's a straight angle, and you know part of it is 160. So you know, since you're missing a part, you subtract. And that's when we find that this is a 20-degree angle. So when you're working problems like this, I want you to remember to find out what you're missing. Are you missing a part, or are you missing a whole? And that will tell you whether you need to add two parts to get the whole, or subtract whole minus part to find your missing part. Good luck. You're going to do great.